right, guys, we're going to continue our review of these of the strength of materials properties, and today we're going to be talking about modulus of elasticity, which is symbolized with the capital letter E. So the best way to describe modulus of elasticity is that it's describing the stiffness of an object based on what that material is made of. So if you remember, the moment of inertia was talking about the stiffness of the material based on its orientation, whether the beam was in a vertical or a horizontal position. This has nothing to do with the vertical and horizontal position. This has to do with what it's made of. If it's made of metal or plastic or wood, that's going to have a factor in how strong that material is. So in general, a higher modulus of elasticity produces a greater resistance to deformation or stretching or bending. So here we have two different materials. This is a plastic beam, and this is a wood Douglas fir beam. So which one will have a greater ability to withstand deformation? Well, it depends on what the material is made of and what its modulus of elasticity is. Okay, so here you have these two beams, and you see the plastic beam. It's a little bit hard to see because it's not that great of a difference, but the plastic beam is bending more than the Douglas fir wood beam. Okay. Why is that so? Well, because the plastic is weaker, and because it's weaker, it has a smaller modulus of elasticity. When we're measuring the amount of deflection or bending, we call that maximum deflection. So this is like when you guys were standing on the beams in the joist and in the plank positions. We were measuring the distance from the floor to the top of the beam before you stood on it, and then from the floor to the top of the beam when you're standing on it. And the difference between those two was what we call the maximum deflection. The factors that determine the modulus of elasticity are these things right here. The amount of force that you put on it, that would have been your weight. The length of the span between the supports, that's the measurement from here to here, how long it is. The modulus of elasticity, and the moment of inertia, the letter I. Okay, so we have these two beams, a plastic beam and the wood beam, and we've got all of the dimensions for the materials right here. They're all the same dimensions exactly. The only thing that's different between these two beams is what they're made of. Okay, one's made of plastic, one's made of wood. So we can calculate the maximum deflection, or how much would the beam bend. Okay, the maximum deflection, how much would it bend, using these numbers here. So we've got the force is right here. We've got the length is right here. Now this is in feet, but we need to have it in inches. That's going to be cubed. The force in pounds times the length cubed divided by 48 divided by the modulus of elasticity divided by the moment of inertia. So we can put the numbers right from the chart into our equation, and this 96 is converted from 8 feet times 12 inches, gives 12 inches per foot, gives us a total length of 96 inches cubed. We always want to do that first. Okay, order of operations. We're going to multiply that by 200. The answer that you get from 96 cubed times 250 divided by 48 divided by the modulus elasticity for this material is 1,800,000 psi, pounds per square inch. And then we're going to divide our answer again by 20.8 inches to the fourth. If we do that, we get a maximum deflection of 0.12 inches. So if we stood on this beam, it would deflect. If a 250-pound person stood on this beam, a 96-inch beam made of Douglas fir, that beam would bend 0.12 inches. Not very much. If we did the same thing with the plastic material, okay, same 250-pound person standing on a 96-inch long beam, the modulus elasticity for the plastic is 419,000 pounds per square inch. So that's a weaker material. It's a much smaller number than the 1,800,000 number of modulus of elasticity for the wood. So when we do this, all this math here, and again, remember, all you have to remember is we're going to cube this first. You're going to get that the beam would bend 0.53 inches. Okay, so it's going to bend quite a bit more than the other one. When we compare them, this one here bent 0.12 inches, and this one here, the plastic one, bent 0.53 inches. So about half of an inch, and the wood one, beam A, was only 1/10 of an inch. So that's how we use modulus of elasticity to determine how much a beam will actually deflect. We actually use modulus of elasticity, and in this one here, since we're both in the joist position, the moment of inertia was the same for both of them. So I hope that helped you out.